Chapter 6, Lesson 4 of Advanced Algebra, looking at solving these polynomial equations that we've been working with. And we're going to solve these polynomial equations the same way that we've been solving these quadratic equations earlier. Two methods that we looked at, solving by graphing using the calculator, and then solving by factoring. Now, you remember when we worked with quadratics, not all quadratics factored, but those that did, it provided a quick way to determine a value for x, because once we have a polynomial in factored form, as we've been talking about throughout this section, is if we had the factored form of the polynomial equal to 0, we can apply the zero product property and determine what value would make each one of those factors zeros, those becoming the solution to our equation, and giving us the point where the graph would cross or touch the x-axis. The problem with these higher degree polynomials is factoring becomes a little bit more difficult. However, we will look at two special cubic polynomials that if the cubic polynomials are in a certain form, then factoring becomes easy. We can factor it and then figure out the values again using the zero product property. The other method that we looked at is graphing, and again, we'll cover that in this lesson. But again, it's a review of something that we've done previously. Now we can solve a polynomial equation by graphing each side of the equation as y1 and y2 in our calculator, and then looking for the intersection. You remember we did this earlier when we were working with polynomials, or quadratics. But if we had a polynomial, let's say 3x cubed plus 7x equals, let's say, 5x to the fourth minus 12, we could figure out the value for x, or solve this for x, by graphing. We would put this side of the equation in as y1, you remember on our calculator. We would put this side of the equation in as y2, and then we would use the calculation function intersection to find out where they intersect, because where the two graphs intersect is the point where they are equal. So you remember doing that with our calculator previously with quadratics, so we can do the same thing here with any size polynomial as well. Now, I will give you one example. It's sometimes easier, in fact, I think it's almost always easier, to solve this equation for 0. Okay, in other words, move everything to one side, then we have it equal to 0, because then we're not looking for the intersection anymore. We're looking for where the y value is 0, and again, that's on the x-axis. Meaning, if I was to take this 3x cubed plus 7x, and then I subtract the 5x to the fourth, so it's on this side, and I add 12, so it's on this side, and I move everything to one side, you'll notice that it's equal to 0. That's a y value of 0. And as we've been talking about, that y value of 0 is on the x-axis. So in that case, I would only need to graph this as y1 in my calculator, graph it, and then look for the intercepts, or the x-intercept, or the 0. I would use the 0 function on my calculator. And the reason I want to do that is because in many cases it's a lot easier to see where it crosses the x-axis than to see where all the intersection points are. So let me give you an example so you can kind of see what I'm talking about here. So for our example here, we have 2x cubed plus 5x squared is equal to 7x. So if I wanted to solve this leaving the equation as is, I could take the 2x cubed plus 5x squared and put that in as one equation, and put 7x in as a second equation, and graph those and look for the intersection. So you'll see here I have 2x cubed plus 5x squared graphed in red, and I have the 7x graphed in green, and you'll notice that there is an intersection point right here. That's what I'm looking for. So if I use my intersection function under my calculate menu and I set it here, I'll get my intersection as 0, 0. So one of these zeros of my graph, or roots, or equations where I'm equal, is at 0, 0. That's one of the points where they intersect. Now the problem here is I don't see any other intersection points in my graph. However, if I adjust my graph like this, you'll notice there is another intersection point up here. So I would have to again calculate that intersection point, use the intersection and put here, and you'll notice I get the intersection point as 1, 7. Now again, those are 2, and that looks like I'm done. However, if I graph, or if I adjust my window even further, you'll notice that there's another intersection point way down here. And you'll notice what my window is at right now. I've got negative 55 on my x-axis and 51 and 34 and 34 on my y-axis. So I really had to adjust my window pretty far out in order to see all the intersection points. And if I calculate that, I'll get a negative 3.5. So you can see I really have to be aware of making sure I look at all the places where these intersection points might be, because I may not be able to see them in my initial window. However, if I move the 7x to the other side and set it equal to 0, my graph looks like this. 2x cubed plus 5x squared minus 7x, and you'll notice I can see, in this case, I know this is equal to 0, so I'm only looking for where it crosses or touches the x-axis. And you'll notice I can see all 3 points in a window that's only a 10 by 10 on my x-axis and only a 6 by 6 on my y-axis. So by putting everything to one side and looking for the zeros of the function, it makes it a little bit easier to see, because sometimes those intersection points can be pretty far out. So I would suggest, when you're solving by graphing, is that you move everything to one side, set it equal to 0, graph that, and then look for the, now in this case we wouldn't be looking for the intersection, we're now looking for the 0. We're looking for the place where it crosses the x-axis. So if I put it here, you'll notice I get negative 3.5, which is exactly what I had on my other one. Then I have to find the 0 that takes place here. That's 0, 0, which was the same as the other one. And then if I take the 0 of this first one, it should be about 1, and you'll see it's 1. So you see I got all of the same answers that I got when I did this. Well, let me adjust this back now, as you can see. Negative 3.5, 0, 0, and 1, 7 that I got when I did it here. So again, putting it equal to 0 and looking for the zeros is usually a little bit easier than looking for the intersections, just because those 0 points are going to be more bunched along the x-axis than the intersection points might be. Okay, so that's how you would solve a polynomial graphically. In the next video, we'll take a look at factoring a couple of special cubic polynomials, which will help us solve those.